Hey guys, it's me again. Today we're going to be learning section 3.1, squares and square roots. So squares, what are they? Squares means two of the same numbers multiplied together. The keyword here, same. Let's consider this example. What is 5 squared? Well, 5 squared is the same as 5 to the power of 2, which is equal to 5 times 5, which is equal to 25. So to answer our question, what is 5 squared? 5 squared is simply just 25. Perfect squares. The product of an integer multiplying itself gives the definition of what a perfect square is. Still not really getting it? Here you go. For example, 36 is a perfect square. So the wheels are turning in your head and you're probably aware that 36 is indeed a perfect square. Why? Well, it's really simple. 36 is the same as 6 times 6. Because 36 can be written as two integers that are the same multiplied together, it is a perfect square. We can also solve for perfect squares using a method called prime factorization, which is breaking down a number into its simplest form. So to practice prime factorization, we're going to start with example 1. So here goes. Is the number 64 a perfect square? And immediately in your head, something should click. You should know that 64 is a perfect square. Why? Well, like 36, 64 can be written as 8 times 8. But how do we prove that 64 actually is a perfect square? This is what we should do. We started with 64 and now we perform the prime factorization method, which is basically just a breakdown of our number into smaller components, or prime numbers. So what I need you to do right now is help me think of two numbers that when I multiply together helps me get 64. So what is it? 1 times 64, well, that doesn't really help. How about 4 times 16? Alright, so this method is called prime factorization for a reason. All our factors should be prime numbers. So we're going to further break down our numbers. 4 can be broken down into prime numbers 2 and 2, and so can 16. We can break it down into 2 times 2, which is 4, times 2, which is 8, times 2 again. So counting our 2's, we have 6 2's. So 64 is equal to 2 times 2 times 2 times 2 times 2 times 2, which is the same as 2 to the power of 6. So remember, we want to figure out if 64 is a perfect square. So we need to break our 6 2's into two even groups. Doing so, I get two groups of 3 2's, which is the same as 8 times 8. So therefore, because we can break 64 into two numbers that are the same, we know that 64 is indeed a perfect square. Square roots. What are they? Are they just like squares? Well, square roots are the opposite of squares. This means breaking the numbers into two of the same numbers. So it's a reverse process of what squares were. We use this symbol, this little squiggly thing, to represent a square root. Example, what is the square root of 36? So this time, we want to break our number 36 into two of the same numbers. And just like before, you should be able to do this in your head. 36 is equal to 6 times 6. So therefore, square root of 36 is equal to 6. Summary. So this is probably your favorite part, guys, because I'm just going to review everything that we've learned today. So squares are when two of the same numbers are multiplied together. If a number can be written as a number squared only, it is a perfect square. So for example, 3 times 3 is equal to 9. 9 is the perfect square because it's written by two numbers squared only, 3 squared. Square roots. That's the opposite of squares. It's breaking a number into two of the same numbers. We find square roots by 1, observation, which is what we should kind of logically know, and 2, by prime factorization, which is when we did that really big diagram of all the prime numbers. So that's it for today. I hope you guys had fun. See you guys next time.